In this video, we'll talk about logarithms and what a logarithm is. A logarithm came about during the Renaissance period when a mathematician, John Napier, found the need to simplify some arithmetic. So it came from the Greek word logos, meaning proportion or ratio, and the Greek word arithmos, meaning number. So a logarithm answers a question like this: 2 to what power equals 8? 2 times 2 times 2 is 8, so 2 to the third power is equal to 8. So we can rewrite 2 to the third power equals 8 as a logarithm. So log base 2, the 3 is over here, and the 8 is over here. So the 3 and the 8 have switched places. The log is always equal to the exponent. So if we're interested in what the exponent is, we can write that as a log. And in essence, the logarithm is the inverse of the exponential. The general case, a to the x equals y. The base stays the same. The exponent, is what the logarithm is always equal to, and what the exponential is equal to becomes the input for the logarithm. So what is log base 10 of 100? 10 to the second power is equal to 100. So log base 10 of 100 is equal to 2. What about log base 3 of 81? We can think about that as 3 to what power is equal to 81. 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So log base 3 of 81 is equal to 4. Sometimes we write logs without bases like this, like log 100, but typically that means the base is 10. We call this a common logarithm, and engineers love to use common logarithms. It shows up in the pH scale, and it also shows up in the Richter scale for measuring magnitude of earthquakes. It is how many times we need to use 10 in a multiplication problem to get our desired number. So example, log of 1,000 is similar to log of what power, 10 to what power is equal to 1,000. And 10 to the third power is equal to 1,000. The 10 there is understood. Another base that's used is Euler's number, which is about 2.71828. It's a number very similar to pi. This is called a natural logarithm, and mathematicians use this one a lot. On a calculator, it's the ln button. So how many times we need to use e in a multiplication to get a desired number? So if we don't write a base, the understood base is 10. If we write ln of x, the understood base is e. So rewrite in an exponential form and determine the value of x. So 2 to the x equals 16. So in that case, the logarithm is equal to 4 because 2 to the fourth power is 16. 2 to the x equals 1 over 8. This is going to be a negative exponent. We talked about that before. So x would be equal to negative 3. 3 to what power is equal to 27? And that would be 3 to the third power. 27 to the what power is equal to 9. This number is smaller than 27. We didn't go over how to do that, so we're just going to skip that one for today. The answer is actually 2/3 though, I believe. All right, so a to the x is equal to 1 over a, and in this case, x would have to equal negative 1. Negative exponent is going to put the a in the bottom, and a has an exponent of 1. ln of 1, we can rewrite this as log base e of 1 is equal to x. So e to what power is equal to 1? The only thing we can raise a number to and get 1 would be 0. In this case, x to the third equals 64. So what to the third power is equal to 64? That's 4. And log base x of 81 is equal to 4. So x to the fourth power is equal to 81. And what to the fourth power is equal to 81? That's 3. Number 9, 10, 11, 12, we're going to be rewriting exponentials in logarithm forms to solve equations. So we could rewrite this: log base 8 of 64 is equal to 2. Remember, the 64 and the 2 are going to switch places. The base is going to stay the same. So log base 9 of 27 is equal to 3 over 2. Log base 10 of 0.001 is equal to negative 3. Remember, the logarithm is always equal to the exponent. Log base 2 of 1 over 16 is equal to negative 4. So far, all of our examples have had whole numbers. Like up here, we could figure these out without really doing a whole lot of work, not really needing a calculator or anything. But if we get something like log base 10 to the 26, so 10 to what power is equal to 26? Well, we know 10 to the first is 26, and we know 10 to the second is 100. 10 to the first is 10, and 10 to the second is 100. So what power could we raise this to get 26? We know it's going to be somewhere between 1 and 2. We could guess and check and guess and check, but we would never actually get the definite answer. So this is hard to figure out, so we would use a calculator. On your calculator, you could type log of 26 in your calculator. And when you type that in the calculator, you'll get the answer. My calculator may be a little different than yours, but we can hit log of 26. That's a base of 10. Understood base of 10. We get 1.41497. 1.41497. What's the natural log of 15? Again, e to what power would be equal to 15? That might be hard to figure out. So we can hit the ln button of 15 in our calculator. And ln of 15 is about 2.70805, approximately. What if the log has a base other than 10 or e? Some calculators, you can actually change the base to represent whatever base you want, but some questions, you're not actually able to change the base. So like number 1, log base 5 of 50, I actually can't type that in my calculator. So what we're going to have to type in our calculator, we're going to have to use the change of base formula here. And in our calculator, we're going to type log 50 over log 5. So we're going to hit the fraction button first, wherever your fraction button is. On top, we're going to type log 50. And in the denominator, we're going to type log 5. And that's going to be equivalent to log 5 of 50. Around there. All right, what about log 4 of 100? We're going to type in the calculator our fraction button. We're going to type log 100 on top, and on bottom, we're going to type log 4. So 4 to what power is equal to 100? 4 to the 3.3219 approximately. And we can check that. We can raise 4 to the 3.3219280095, and we get 100. So we know we did it correctly. We can type fractions in there as well. So for number 3, we would type in the calculator, the fraction button. On top, we would type in log, and we would have another fraction inside the log, 1 over 30. And in the denominator, we would have log of 3. And we know this is going to be a negative number since we ended up with 1 over 30. So we get negative 3.0959 approximately. We can do number 4 the same way.